Good morning, students. Yesterday we discussed about in people of elements the preparation of ammonia. It is nothing but a compound of nitrogen. Ammonia can be prepared by Haber process. In Haber process, gaseous nitrogen and hydrogen reacts to form ammonia. The conditions required are a high pressure of 200 atm and a temperature nearly 700 Kelvin, and iron oxide as a catalyst along with promoter K2O and Al2O3. We can get nearly 10 to 20% ammonia. The unreacted gas again passed in a recycling pump. Again it is compressed and it is passed to a catalytic chamber and ammonia is prepared. So you will get 3 marks question. Explain the process of ammonia, which is designed by Haber process of ammonia, which can be asked for 3 marks. Just write the equation and condition, and then if flow chart is asked, you have to draw the flow chart very clearly. See, while going the class, we can observe nearly 140, 180, not more than 200 watching. Dear students, if you have internet accessibility, you have to watch at the time only. Okay? If any net problem, download it to some other place and again you have to watch clearly. Okay. We shall continue our discussion on P block. See, we studied about preparation of ammonia. Ammonia can also be prepared by ammonium salt. Take for example, salt of ammonium chloride. So when it is treated with calcium hydroxide. So you will get ammonia. See, ammonia is called NH3 plus Cl2. So therefore it must be 2, and you will get ammonia and water plus 2 H2O to ammonia. Say calcium chloride, just balance. How many hydrogen here? 4 hydrogen, and here 4 to the 8, and here to 10, and here 6, and here 4. Hydrogen is balanced. Calcium chloride and oxygen. See, 2 oxygen elements are there. Balanced. Ammonia can also be prepared by the decomposition of the salt by using calcium chloride, calcium hydroxide, or even by sodium hydroxide also. So it can also be prepared. For example, ammonium sulfate, a salt of ammonium sulfate. When it is treated with sodium hydroxide, so we will get ammonia NH3 plus sodium sulfate Na2SO4. So therefore it must be 2, and how many hydrogen? And here 1 is here, 3. You can balance this. See, Na2SO4, ammonia and water. So by using ammonium sulfate and in the presence of an alkali. So here it is 2NH3 and 2 NH4 SO4 Na2SO4 only Na2SO4 we will get ammonia only we can balance it. See here ammonium sulfate reacts with sodium hydroxide you will get ammonia along with ammonium sulfate and water molecule. Are you clear? Okay. So by these two methods also we can prepare ammonia. See, even ammonia can also be prepared by urea. So, in bacteria, you can find in soil urea. So, urea, which is nothing but the formula, see, NH2, CO, NH2. Again, when it is with water, and you will get ammonium carbonate, NH4, twice, CO3. Is 2H2 ammonium carbonate and again you will get 2 ammonia plus CO carbon dioxide gas is phosphorus. Okay, it can also be prepared by urea. There is a formula for urea NH2 CO NH2. Say in presence of water you will get ammonium carbonate. See ammonium carbonate of heating you will get ammonia. These are the other methods to prepare ammonia. So ammonia can be prepared by itself, salt only, like ammonium chloride and ammonium sulfate. Ammonium sulfate. See ammonium chloride is treated with calcium hydroxide, which is nothing but a lime. Then we will get ammonia. Then again ammonium sulfate we will get ammonia. And urea we will get ammonia. So these are the other methods in which ammonia can be prepared. So totally we can prepare ammonia by Haber process, which can be asked for 3 marks, and again from its salt and also by urea. These are important preparation of ammonia. See ammonia, its physical and chemical properties we have to study. In its physical properties, ammonia is a gas and it is basic in nature. Basic in nature. So its melting point and boiling point is also more as compared to other hydrides of 15th group. So it is due to strong hydrogen bond. So boiling point of ammonia is more than other hydrides because due to the hydrogen bond. We cannot find hydrogen bond in other elements of 15th group because nitrogen is more electronegative. In molecular form, it forms inter-hydrogen bond. So therefore, its boiling point is more. So it is a strong base. Ammonia is strong base. See ammonia and H3. Presence of a lone pair. Presence of a lone pair. It can easily donate a pair of electron towards an electron deficient species. So you studied in first phase Lewis base. Ammonia is a very good Lewis base. Base is a substance which donates pair of electrons according to Lewis. So studied in first phase. So therefore it's a very good base. And other chemical properties you have to study about ammonia. And ammonia is highly soluble in water. Highly soluble in water. Ammonia, NH3. When it reacts with water, see you will get NH4 plus, NH4 plus, NH4 plus OH minus hydroxide. So which is aqueous and aqueous. So it is highly soluble in water and it forms the solution of ammonia is called ammonium hydroxide, which is a weak base. Frequently, we are going to use in the laboratory. We studied in detection of elements in first phase. In third group detection, you are going to use ammonium hydroxide. It is nothing but an ammonia solution. Okay. Then, what are the other important chemical properties of ammonia? have to remember, ammonia is a very good base due to the presence of lone pair of electron. It is also called it as a very good Lewis base. Okay. Then in chemical properties, ammonium hydroxide, which is nothing but solution of ammonium hydroxide, NH4OH. So any salt, take for example zinc sulfate. These ammonia solution can precipitate any salt into its hydroxide. Have you got the point? Ammonia solution, which is nothing but ammonium hydroxide, it precipitate metal salt into its hydroxide. Take for example, see zinc sulfate. When it is treated with ammonium hydroxide, you will get, see zinc hydroxide, ZnOH5, which is nothing but a white precipitate. We can easily detect zinc ion and we will get, see NH4 twice. That's it. You can balance. Are you clear? See, ZnSO4 plus 2 ammonium hydroxide molecule and you will get zinc hydroxide. The chemistry you have to remember behind is ammonium solution or ammonia solution, which is nothing but ammonium hydroxide. It precipitate other salt into hydroxide, say which is used in qualitative analysis. Okay. So again, it can precipitate even iron chloride into ferric hydroxide. Precipitate will get. So this is one important chemical property of ammonia solution. And again, ammonia forms complex compound with the elements like copper. See copper, which is in aqueous copper 2 plus. When it reacts with ammonia, 4NH3, you will get a complex compound. See NH3, 4 times 2 plus. So which is nothing but the blue color. See copper 2 plus, which contains one unpaired electron, copper sulfate. You know that chemical. So this you will get a deep blue color. So this is used in the estimation or detection of copper ion. Copper reacts with ammonia, it forms a complex compound. So it is nothing but the tetra copper 2 ion. So you have to study again coordination compounds. So it forms a complex compound. Again it reacts with a precipitate of silver chloride, a white precipitate. So when it reacts with ammonia, 2NH3. So you will get a complex compound AgNH3 twice, Cl. So which is nothing but diamine silver chloride. So here tetraamine copper 2 ion. So you have to study in detail in coordination compounds. What are complex compounds? How they are formed? What are their characteristics? We will study in next topic. Here you have to remember, ammonia forms complex compound with the elements like copper according to what syllabus and even in silver ion. See silver as precipitate as silver chloride and you will get here, so it's a white precipitate and here you will get a colorless. So that precipitate vanishes. So that is nothing but, see, tetraamine silver chloride. How to read that? Tetraamine copper 2 ion and diamine silver chloride. Okay, these are some important chemical reactions of ammonia. Are you clear? Dear students, you studied some of the important chemical reactions of ammonia. Ammonia is highly soluble in water. It forms its hydroxide, and that hydroxide is a weak base. Then, ammonia solution, it precipitates salt, any salt, into its hydroxide. According to your zinc sulfate, then iron chloride, they can be precipitate as its hydroxide, which can be used in qualitative analysis. And then again ammonia reacts with copper ion in aqueous condition, which is a blue color copper ion. When it reacts with ammonia, you will get deep complex, deep blue color complex. And white precipitate of silver chloride, see, the precipitate will be colorless by forming a complex diamine silver chloride. So these are important properties of chemical properties of ammonia. So what are the uses? Ammonia is used to prepare ammonium nitrate and many fertilizers, and it is also as in a refrigerant in order to preserve some biological organisms. These are important uses of ammonia. Are you clear? Okay. So you studied compounds of dinitrogen. One is dinitrogen, another one is ammonia. So you have to study different oxides of nitrogen. Next part of the says different oxides of nitrogen. Different oxides of nitrogen. See, those oxides are, I already told you, due to its variable valency, oxidation state, nitrogen forms variety of oxides. Those oxides are, see, N2O dinitrogen oxide, then NO, which is nothing but nitric oxide, then N2O3 dinitrogen trioxide, then NO2 nitrogen dioxide, and N2O4 dinitrogen tetroxide, and nitrogen pentoxide, N2O5. Are you clear? These are the important oxides of nitrogen. You have to study its physical characteristic as well as its preparation. Sometimes it will be asked, but better to understand. And even you can write a bond length diagram also, even Lewis dot structure, you studied in first basic. See, here N2, what is the oxidation state here? Say oxygen 2 minus sulfur, it is +1, its oxidation state is +1. And it is a colorless gas, and it is neutral. It is neutral oxide of nitrogen. Sometimes for CET also you will get question whether it is acidic, neutral, basic, or none of this. So again, go for nitric oxide. So it is also a neutral, colorless gas. It is a colorless gas, and dinitrogen oxide is also a colorless gas. What is the oxidation state here? Its oxidation state is +2. Are you clear? The next N2O3, say nitrogen trioxide. O3 here 6. Therefore, its oxidation state is +3. So this nitrogen trioxide is a blue color solid. It is a blue color solid. You can find nitrogen dioxide, which is nothing but a brown gas. This is nothing but a brown gas. So its oxidation state is plus 4, and even in nitrogen tetroxide also you can find here its oxidation state 8. Here also its oxidation state is 4. And nitrogen pentoxide, its oxidation state is plus 5. And nitrogen dioxide, which is a brown color gas, which is acidic in nature. It is acidic. Only neutral oxide, one is dinitrogen oxide, another one is nitric oxide. Both are neutral, and it's acidic, is also acidic, is also acidic, is also acidic. And nitrogen tetroxide is a colorless gas, liquid or solid, and nitrogen pentoxide is a colorless gas. Is a colorless gas. So physical properties of these oxides can be asked for 1 mark. Are you clear? Okay. So we shall study its preparation. See, this dinitrogen oxide is prepared by heating. See, ammonium nitrate, NH4. So you will get. See, N2 plus N2O plus 2H2. How many hydrogen atoms are there? 4. You can balance. See, 2 nitrogen from nitrate and ammonium. So just we have to heat, we can prepare dinitrogen oxide. How it can be prepared? By heating ammonium nitrate. Just remember that. So it is a neutral, colorless gas. What I will say? Oxidation state. Its oxidation state is 1. Okay. Then see, you have nitric oxide. So nitric oxide can be prepared by sodium nitrite, not nitrite, and FeSO4 ferrous sulfate, and then bypassing in the presence of concentrated H2SO4, which is right equation. So you will get Fe2SO4 thrice. See, iron in +2 oxidation state is oxidized to +3 oxidation state. So therefore, this is ferric sulfate. Ferrous sulfate is oxidized to ferric sulfate. Then we have sodium bisulfate, 2NaHSO4 plus how many hydrogen atoms? 6. 2 are used, plus 2H2O and plus 2NO. Are you clear? So this is nothing but nitric oxide. Very lengthy equation, very easy. Are you clear? How nitric oxide is prepared? Nitric oxide is prepared by the reaction between sodium nitrite, ferrous sulfate, and concentrated H2SO4. It reacts each other, and here ferrous sulfate is converted into ferric sulfate. Another salt element is sodium bisulfate. Water molecule and nitric oxide. Are you clear? So we can easily prepare nitric oxide. Then we have nitrogen trioxide. So it can be prepared by nitric oxide and nitrogen tetroxide. So just we have to heat at 250 Kelvin. We will get see N2O3. So how many oxygen atoms are there? Here 4, here 2 6, 2 3 is a 6. nitrogen 2 and 2 here, so it is balanced. When nitric oxide is heated with nitrogen tetroxide at 250 Kelvin, so nitrogen trioxide is obtained. Are you clear? Okay. Then how can we prepare a brown gas nitrogen dioxide? It can be prepared by heating lead nitrate PbNO3 twice. 2 ppm twice. When it is heated at high temperature, nearly 673 Kelvin, 673 Kelvin, lead nitrate, and you will get 2 PbO lead dioxide plus 2 NO. See 2 to the 4 N. How many nitrogen atoms are here? Here 2. NO3 twice, 4 nitrogen atoms. So it is balanced. 2 lead oxide and 4 NO2. Are you clear? How nitrogen dioxide brown color gas is prepared? By heating lead nitrate. See PbNO3 twice at 673 Kelvin temperature. We will get nitrogen dioxide. Nitrogen dioxide is a brown color gas. Are you clear? Okay. Then you have to study nitrogen tetroxide. So it can be obtained by cool or heat, and you will get N2O. So it is nitrogen dioxide gas on silent cooling as well as it is a reversible reaction, and we will get dinitrogen tetroxide. Are you clear? So it can be prepared with nitrogen dioxide only, no other gas only. Are you clear? So whatever is physical state, it may be solid or liquid state. On cooling, slowly it goes to solid state. Okay. So nitrogen tetroxide. Again, nitrogen pentoxide, dinitrogen pentoxide. It can be prepared by nitric acid, 4HNO3, and along with phosphorus pentoxide, P4O10. I write this equation at the top. See, 4HNO3 plus P4O10, which is the phosphorus pentoxide. So on heating, we will get see 4HPO3 type of phosphorus acid. We have studied different acids of phosphorus. Right? So you will get N2O5. See how many nitrogen atoms are there? 4. Therefore, it should be 2 N2O5. How many oxygen atoms are there? 10. It can be easily balanced. See 2 N2O5. Just see the chemical equation. 4HNO3 nitric acid. When it reacts with phosphorus pentachloride, you will get HPO3. See 4 hydrogen atom and 4 phosphorus atom are consumed here, and oxygen here 4 3s are 12 and here 10, 22 here 10 and here 4 3s are 12, 22 is balanced. Just see the balancing of equation and what are the reactants and the products. Stick on, concentrate the type of oxide we are going to prepare. The type of oxide and write according to the equation. Balance the equation. Okay, so we can prepare different oxides of nitrogen, and we have to remember very specifically the physical state and their characteristics, whether they are neutral, acidic, or basic. Acidic. See, only two oxides, N2 and NO, are neutral, and all other oxides are acidic in nature. Are you clear? Understood? Okay, practice the equation. You can easily relate. See, among the bond parameter and all its Lewis dot structure, you can easily write. You studied in first PUC. See, nitrogen dioxide anode contains one odd electron. So that all you studied in first PUC. Even though I will show you one nitrogen pentoxide, how to write its resonance. Okay, are you clear? Shortly, I will send the notes. Don't worry. Now, say N2O5, N2O5. It's a resonance structure you can write. Dinitrogen pentoxide. See, this is nothing but the nitrogen is bridged with an oxygen atom, two nitrogen atom, and here oxygen. Are you clear? Now, you have to check with the Lewis dot structure. Okay. We shall study and see. This is nothing but oxygen, 6 valence electrons. See, 1 is here, 1, 2, 3, 4, 5, 6. See, nitrogen, 5 valence electrons. How many? 5. Those are, see, 1 is paired here, and this is nothing but a single bond, and all the 6 electrons for this oxygen, and these 2 electrons for the nitrogen. And again, 1, 2, 3, 4. Again, it's pair here, by a double bond. And how many electrons remain? 1, 2, 3, 4. Totally for the oxygen, 6. 1, 2, 3, 4, 5, 6. Understood? Okay. See, nitrogen, 5 valence electrons. 1, 2, both are from nitrogen. 3, 4, and another one is 5, which is bonded with oxygen. Okay. For this oxygen, again 1, 2, 3, 4, 5, 6. See, one with nitrogen, and another. See, this is nothing but a double bond. You can easily understand now. And this is again a single bond. This is again a single bond. Again, how many? See, 6 pairs of electrons are here. See, how many electrons you can accommodate here? See, here 5, 1, then 2, 3, and this is nothing but pair, and here also it is 1. Are you clear? So this is 2, 3, 4, 5. And oxygen 6 electrons are here only. Are you clear? So you can write another resonance to this. Another resonance. See again, what is the resonance? See, one is as same structure, which is bridged with oxygen. This is bridged with oxygen. Again, this is the single bond here, and this is here double bond. How many electrons are here? 8 electrons. And here, one oxygen is the same double bonded. 1, 2, 3, 4, 5, 6. So this is nothing but a resonance. See, even bond parameters. Just practice and study these all in one stage. Easily we can write. First, judge the valence electron and write the structures. Are you clear? Okay. So this is nothing but different oxides of nitrogen. Nitrogen shows variable oxidation state by seeing their oxides: dinitrogen oxide, nitric oxide, nitrogen trioxide, nitrogen dioxide, nitrogen tetroxide, and nitrogen pentoxide. Familiar chloride equation also. Physical characteristics, oxidation state. If you just repeat, just understand, you can easily write. Okay, this completes our study on the element nitrogen oxidation state. That means oxides of nitrogen. We shall continue our study on preparation. Another very important compound of nitrogen is nitric acid. How nitric acid is prepared? In the laboratory, nitric acid is prepared by potassium nitrate or sodium nitrate in the presence of sulfuric acid. In presence of sulfuric acid. Are you clear? Now we are going to study nitric acid. What is the formula for nitric acid? HM3. Nitric acid. Nitric acid. Are you clear? Nitric acid can be prepared in the laboratory by reacting potassium nitrate with sulfuric acid. Sulfuric acid. So you just replace one hydrogen here. So you will get nitric acid HNO3 along with potassium but sulfate KHSO4. Even with sodium nitrate, when it reacts with concentrated H2SO4, you will get again nitric acid, and you will get sodium persulfate, HSO4. Are you clear? You can easily prepare nitric acid in the laboratory. But on a large scale, nitric acid is prepared by post-wall process. Are you clear? On a large scale, it is prepared by post-wall process, which can be asked for 3 marks. Very important. We shall study the preparation of nitric acid by post-wall process. So, what is the theory behind this? What are the chemicals used? Just you listen. Afterwards, we shall write the equation. Okay. See, post-wall process for the preparation of nitric acid. You know the basic concept of nitric acid. Nitric acid is a strong acid, really an oxidizing agent, which is corrosive also. Because of its high strength, it can react with many metals, many compounds. Okay. Such an important strong acid, even in our day-to-day life, in the preparation of many nitrates, is used. So we have to study the preparation of nitric acid on a large scale. That is nothing but post-wall process. Preparation of nitric acid is nothing but post-wall process. Post-wall process. So you have to concentrate its chemical equation. So orally I will tell you what are the things in post-wall process. See, in post-wall process, the ammonia is oxidized by using catalyst platinum and rhodium, that gas, at a temperature 500 Kelvin and nearly a 9 bar pressure. Ammonia is oxidized to nitric oxide, NO. Are you clear? What is the first step? Ammonia is oxidized by atmospheric air in the presence of platinum and rhenium gas as a catalyst. Rhodium as a catalyst RH at a 500 Kelvin temperature and 9 bar pressure. ammonia is get converted into nitric oxide, NO. So I write the equation. What is the step 1? Oxidation of ammonia. See, ammonia is converted into what? Nitric oxide. Here, ammonia NH3, it is oxidized by air. So, in the presence of platinum and rhodium RH as a catalyst at 500 Kelvin temperature and 9 bar pressure. So, it gets converted into NO and H2O. But the valence is equation 4 NH3, then 5 O2, and it is 4 NO, which is a gas, and here water. How many hydrogens are there? Therefore, it is 6H2. It is nothing but oxidation of ammonia. This step is called oxidation of ammonia. See, electropositive element is removed. You are going to add electronegative element, more electronegative, and so therefore this step is called oxidation. The condition is very important. Simply you wrote the equation now. You have to write by word. Ammonia is oxidized in presence of platinum, rhodium as a catalyst. Then at 500 Kelvin temperature and at 9 bar pressure. So, nitric oxide is formed. In step 2, the formed nitric oxide NO is oxidized to form NO2. So just balance. Again it is oxidized. The second step, oxidation of NO2. Again bypassing it. Are you clear? Okay, in the last step, in the third step, see it is diluted with water. So dilution with water. 3NO2 plus water, and you will get nitric acid. 2HNO3 plus again nitric oxide is formed, which can be recycled again. So these are the 3 important steps in Ostwald process. See, actually in a process, in a tank you have to pass ammonia gas and you have to maintain the temperature by passing air. Nearly 1:10 ratio you have to take, and it is passed through air, and then it is oxidized to nitric oxide, and then it is put in absorbed tower, and where it is oxidized, and again it is absorbed with water, and finally you will get nitric oxide. So whatever the nitric acid you got, is only 68%, and that is again, see, when it is again treated, it is condensed concentrated sulfuric acid, we will get nearly 98% nitric acid. So whatever the nitric acid obtained by Ostwald process is only 68%, and that is again condensed by using concentrated H2SO. All water vapors absorb, and nearly we will get 98%. Here we can get 100%. By freezing the mixture, we will get 100%. Are you clear? So there is no flow chart, no diagram, only equation and the condition of the remove. So this is nothing but preparation of nitric acid by Ostwald process. Okay, as soon as our maths class is going to start just 20 minutes late. Again, physics class going to take and stop my discussion here. So again, I am going to repeat about preparation of nitric acid by Ostwald process. Are you clear? So ammonia is oxidized to nitric oxide. Again NO is converted into NO2, and on heating with water we will get nitric acid. The obtained nitric acid is only 68%, and again it is condensed by using concentrated sulfuric acid. 98% pure nitric acid can be obtained. This process is called Ostwald process. Condition you have to remember is platinum and rhodium as a catalyst, then 500 Kelvin temperature and 9 bar pressure. Just remember, balance 45, 46. As you are enough, just you repeat, recall and write. Okay, thank you students. Shortly, I will give the notes.